This is a CCEA AS Pure Maths paper. This one's from May 2022, and we're taking a wee look here at question number 8. So 2 parts to this. Solve 0.7 to the power of x is less than 5. So we need to take logs of both sides here because we have an index. So it's going to be log 0.7 to the power of x is less than log 5. Laws of logs mean we can bring the x to the front. And the next wee bit's crucial. We now want to divide by log 0.7. Now I hope you know this already, but log 0.7 is a minus number. So whenever we divide an inequality both sides by a negative, the inequality flips round. So that means our next line is going to be x is greater than log 5 over log 0.7. Sorry, I'm not sure we have an equal sign in there. And that means then x is greater than, and if I do log 5 divided by log 0.7, I get minus 4.51. That's my answer. Below shows a sketch of a curve with equation y equals 8 minus x cubed. We have that. Find the maximum area of a rectangle which can be inscribed in the closed region bounded by the curve on the positive x and y axis. So we have it here. I guess we can have this wee rectangle here. We could have this rectangle here, and we're trying to maximize that. So there's going to be a bit of calculus involved here in terms of what we have. So the length of this here, so this is the coordinate x, y. I hope you can see then the length of that's going to be x, and that's going to be y, and that's what we're trying to find. And so we're trying to find in our area. So our area is going to be x, y. That means our area is going to be x upon, we know y is related then to x. So it's going to be then 8 minus x cubed. And our area then is 8x minus x to the power of 4. We're trying to maximize this, so we want to differentiate. So it's going to be dA by dx. That gives me 8 minus 4x cubed. And to find the maximum, dA by dx equals 0. So that obviously means an 8 minus 4x cubed equals 0. That gives me, rearranging, x cubed is 2, and x is then going to be the cube root of 2. Our value then for y, 8 take away the cube root of 2 cubed. The cube root of 2 cubed is obviously going to be 2, so it's going to be 8 take away 2, and then y equals 6. So find the maximum area. So it's the cube root of 2 times 6. So let's see if we have a cube root button. I'm not sure we do. I think that's it. Cube root of 2 times by 6, and I get then 7.56 units squared. Right, I'm almost there. I just need to prove that this is indeed a maximum. And I'll see if I can fit it just into the page here, but feel free to obviously to take our next page. So we need to differentiate again. We need to work out d2a by dx squared. So there's dA by dx, that 8 disappears, and I end up then with minus 12x squared. Whenever I sub in this number here, I don't know what I get, but I know that it's less than 0 because it's going to be a negative. Therefore, it is indeed a maximum. So that's worked that out.